Good morning, everyone. The subject is Machine Tools at Metallurgy. My name is T. Dharmateja and roll number is 20851 and the topic is turning the electric motor outside. Inside an electric motor, an electromagnetic is the basis of electric motor. Says you created a simple electromagnetic by wrapping 100 loops of wire around a nail and connecting into the battery. The nail would become a magnet and have a north and south pole while the battery is connected. Now say that you take your nail electromagnetic run an axle through the middle of it and suspended in it the middle of horse show magnet as shown in the figure illustration. If you were to attach a battery to the electromagnetic so that the north pole end of the nail appeared as shown, the basic law of magnetism tells you what would happen. The north end of the electromagnet would be repelled from the north end of the horseshoe magnet and attached to the south end of the horseshoe magnet. The south end of the electromagnetic would be repelled in a similar way. The nail would move half a turn and then stop in the position shown. How a DC motor works. As we maintain, you encounter the two types of electric motors, direct current and alternating current. The later direct current or DC motor were first developed in the mid 1800s and they were still used today. The outside of DC motor is a stator, a permanent magnet that does not move. The inside part of the rotor which does move. The rotor where here the rotor here is like the nail in our previous example, and the stator is like the horseshoe magnet. When DC power is sent through the rotor, it creates a temporary electromagnetic field that interacts with the permanent magnetic field of stator. The commutator's job is to keep the polarity of field flipping with which helps the rotor rotating. This creates the torque needed to produce a mechanical power. Toy motor. The toy DC motor pictured in the small about as big around as a dimple with two battery leads. If you hook the battery leads of motor up to a battery, the axle will spin. If you reverse the leads, it will spin the opposite direction. The nylon end cap is held in the place by two tabs inside the end cap. The motor's brushes transfer power from the battery to the commutator as the motor spins. Because the brushes can wear out and the need replacing modern DC motors are often brushes. The axle holds the rotor and the commutator. The rotor is a set of electromagnets. In this case, three. The armature is not motor is set of thin metal plates stacked together within the copper wire coupled around each of the three poles of the rotor. The two ends of each wire are attached to a terminal and then each of the three terminals is wired to one plate of the commutator. Rotor and commutator brushes. As we need earlier, this rotor is like the nail is our diagram of electromagnet. The commutator is also attached to the axle. Commutator is simply a pair of plates attached to the axle. The plates provided the two connections for the coil of the electromagnet. The flipping is an electric field. Part of electric motor is accomplished by two parts, the commutator and brushes. The diagram shows that the commutator in green and brushes in red work to work together to let current flow to the electromagnet and also to flip the directions that electrons are flowing at just the right moment. The contacts of the commutator are attached to the axle of the electromagnet, so they spin with the magnet. The brushes are just now pieces of springly metal or carbon that makes contact with the contacts of commutator. How an AC motor works. Now we're going to look the AC motor. AC motor using alternating the current instead of direct current. It shares many parts with a DC motor, and it still really relies on electromagnetism and flipping magnet field to generate a mechanical power. The parts inside a AC motor are stator, rotor, solid axle, coil, squirrel cage. The winds of the stator is in a AC motor kind of does the job of the rotor of a DC motor. In this case, it's ring of electromagnets that are paired up and energized in a sequence which creates the rotating magnetic field. AC motor and stator. The key to an AC induction motor where the field of the rotor is induction by the field of stator, in that the motor rotor is always trying to catch up. It always looking for a static, so it's rotating to find that a steady state, but the electromagnetic field produced by a stator using AC motor is always going to light faster than the rotor's field. The spin of the rotor is creating the torque needed to create a mechanical power to run the wheels of a car or the rear of a fan. Some AC motors use wound rotor, which is wrapped in a wire instead of being a squirrel cage. The squirrel cage is kind of more common, though in the either cases there is only one moving part in AC motor, which means there are few things that needed to replacing or maintenance. Thank you. Thank you for giving this wonderful opportunity to share my views. Thank you, and all.